Okay, we're gonna continue our discussion about the mole calculations. Let's take a look at a few more calculations here. So first of all, let's look at the if we have 1.5 gram of sulfur, can we find out how many moles of sulfur? Now, before we answer this question, okay, you know, you can quickly check if you can do this or not, but this question is not there yet. From mole of sulfur, you know, imagine mole is dozen, okay? Can you find out how many sulfur, since sulfur is a pure element, right? So the individual unit of sulfur element is atom. All right, so let's take a look at this one. Okay, so this is going to be eventually finding the number of atoms of sulfur. Okay, so it's going to be starting from 1.5 grams of S, which is the symbol of sulfur, times the first thing you're going to find out is the mole of the sulfur. Okay, we already said a number of times. The mole is the connection or the bridge connecting the very useful physical amount in grams for us in the lab, or practically useful for us with the number of atoms or molecules that's kind of super tiny things. Okay, so mole is always going to be in the middle of the calculation, as working as like the bridge or intermediate. Okay, so starting from 1.5 grams, and what you're looking for is the mole of sulfur, and obviously by default you won't get rid of gram of sulfur, so this is the way it looks. So the first conversion, okay, is going to be you need to go to the periodic table, find the molar mass of the sulfur, since this is grams and the mole. Okay, so you will find for the first step you need 1 mole sulfur equals to 32.07 grams. Now, usually people will write like this, or people can write like this, okay, sulfur is 32.07 gram per mole. This is the same thing. Okay. This equals to this whole expression here. This is usually how people write the molar mass of anything. How many grams / per mole. So that means every 1 mole of sulfur weighs 32.07 grams. Now you can calculate out this number, which is going to be 0.047 mole of sulfur. Okay, given that 2 sig figs, and so you keep 2 sig figs here. Okay, and the next one is going to be find from the mole of sulfur, find the number of atoms. So 0.047 mole of sulfur times. Now here the conversion between the number mole and the number atom is going to be 1 mole of things will be 6.022 times 10 to 23rd of atoms, sulfur, 1 mole of sulfur elements. Okay, so now the conversion factor here will look like this. Since you start with a mole of sulfur, so mole of sulfur will be down here, and the atom of sulfur will be up here. So if you have 0.047 mole, then that means you have every 1 mole is 6.022 times 10 to 23rd. Okay, now this is going to give you a number that's going to look like, by the way, you're still going to keep 2 sig figs. Okay, 2 sig figs. Alright, so I want you to take this time to 2.8 times 10 to 22nd. The unit will be atoms of sulfur. Okay, so you can see this is going to be a 2-step calculations. You go from gram to mole, and mole to the number of atoms. Okay, let's take a look at another example. Now, if you have, we're gonna make a crazier number, okay? If you have 1.37 times 10 to negative 5 grams of silicon, can you find how many silicon atoms in this sample of silicon? So this is between grams and atoms. Like we always say, okay, you have to go from gram to mole and then to atoms, okay? So this is going to be two-step calculations. You can do as the early example, we do two separate steps, or you're going to do one long step. Okay, we're going to show you here. Again, feel free to pause the video at any time to try yourself, okay? So you want to go from this given number of grams of silicon times the dash line. So, before you put in anything, you know that your first target is to find the mole of silicon. Okay, and then from that, the second target will be the number of atoms of silicon. So your desired units is always going to be on the top for each step. And the first unit you're trying to get rid of is the gram of silicon down here. And the second unit you are trying to get rid of is the mole of silicon. So gram of silicon will be canceled, mole of silicon will be canceled as well in this order. So at the end, you would only have atoms of silicon left over. Now let's fill in numbers, okay? Now from gram, the first step is from gram to mole conversion. Do you see that? So you need to find out the molar mass of silicon. Molar mass of silicon is actually 28.08 grams per mole. That means every 1 mole of silicon weighs 28.08 grams. Again, this is a number you can look it up from the periodic table. Okay, now technically you're dividing this many grams over this. Now once you divide this over the molar mass, okay, you get the mole of the silicon. Now every 1 mole of silicon, there are 6.022 times 10 to the 23rd atom of silicon. So by looking at where the mole of silicon is, you're going to fill in number 1 down here, and the Avogadro number goes with the number of atoms. So it's going to be 6.022 times 23rd on top. So basically the math goes like this. This number, okay, divide by this number and multiply by this number. Now just make sure you use your calculator carefully, okay? And also keep in mind, okay, I think I forgot to mention this, both molar mass, which is from periodic table, and the Avogadro number, which is a defined number, they both are exact numbers. Means you don't have to count sig figs of them. So you only need to look for sig figs information from the first number, which has 3. So your answer should only have 3 significant figures, which is going to be 2.94 times 10 to 17 number of atoms of silicon. All right, let's take a look at another one. Now in this one, you're going to have a given number that's 8.9 times 10 to 22 atoms of manganese, and you're asked for to get the number of grams of manganese. You see, that's a very small unit, that's a very big unit, okay, you can measure in the lab. So in between, you have to find the mole. Okay, you always convert something else into mole first, and then go from mole to whatever you were looking for, okay? So feel free to pause here to try it out yourself. All right, so this calculation starts from 8.9 times 10 to 22nd atoms of manganese. I'm looking for mole of manganese first, as we have planned. So I'm trying to get rid of atoms of manganese. Okay, by this point you should know that the converting factor is going to be Avogadro number. So every 1 mole, always going to have 1 mole, okay, equals the number goes with the atom is going to be that big number, 6.022 times 23. Now, by doing this, you basically got rid of the atoms manganese, you got the mole of manganese by basically dividing the original number by the Avogadro number. Now, this mole of manganese should be gone by having another mole of manganese down here. When I say you can cancel things, so keep in mind, okay, it has to be the same units of the same chemical. Okay, it has to be identical dimension of or quantity, not the number, the dimension. Okay. Now you're looking for the grams, so up here should be grams of manganese, and which is reasonable. You are looking at a molar mass. Okay, every 1 mole of manganese, you can look it up on periodic table, weighs 54.94 grams. So that's a given number, as long as you're given a periodic table. Okay, so the math goes the first number, divide by Avogadro number, and multiply by the molar mass. Okay, and keep 2 fixed at the end, as the other two numbers are exact numbers. So you're going to end up with 8.1 grams of manganese. Okay, so this is the calculation of mole of pure elements.